Hello everyone, hope you have completed textbook sums up to the point of intersection of two lines which we have completed in the previous episode. If you haven't done yet, please go through it and then approach sums from your textbook. If possible, a few JEE sums you are able to do now on straight lines in theory. But the knowledge is not completed yet. You have to learn few more things, that is perpendicular distance of a point from a line, and then image of a point on a line, and then the shortest distance between two skew lines and two parallel lines. So without wasting time, let us start understanding how to find perpendicular distance of a point from a line. So let us start with the scalar form of a line and a point. Let the point be x0, y0, z0. We want to find perpendicular distance of this point from the line whose equation is given in scalar form. This is a line. Line be x minus x1 by a, y minus y1 by b, z minus z1 by c. This is the line. You need to find this perpendicular distance, AL, where L is the foot of perpendicular. The concept is very simple. To get the perpendicular distance AL, we need to get this point first. There is a point on this line, and if we join A to L, the line segment joining A to L will be perpendicular to the given line. Line is this. A point on the line we need to find which will ensure that when we join A to L, it is perpendicular to the line. So we start this way. We take an arbitrary point on the line. Let this is equal to lambda. Assume that. Then x equal to x1 plus a lambda, y equal to y1 plus b lambda, z equal to z1 plus c lambda. Lambda is a scalar, you are habituated because we have done sums based on it. Lambda is a scalar over there. And this point B, let that point L be this one. L is also a point on the line, no? So you can take the point on the line this way, z1 plus c lambda. Now, AL is perpendicular to the line given. So, if we want to find direction ratios of AL, so that we can use the condition that A1, A2, B1, B2, C1, C2, 0, then it will be easier. Dr's of AL, let us write first. It will be x1 plus a lambda minus x0, y1 plus b lambda minus y0, z1 plus c lambda minus z0. Okay? So these are direction ratios of the line segment AL, since AL is perpendicular to the given line. Therefore, we can use the condition of perpendicularity, that A1, B1, C1 given here, we found it here, and this is ABC. So, A into x1 plus a lambda minus x0 plus b into y1 plus b lambda minus y0, C into Z1 plus C lambda minus Z0 equal to 0. Okay? So this implies A into plus B into this is equal to, we take the terms containing lambda on right side. This is minus lambda into A square plus B square plus C square. So lambda going to be A into x1 minus x0, B into y1 minus y0, C z1 minus z0, that divided by A square plus B square plus C square, and negative of it. Lambda equal to minus of this thing. So once we get lambda, then perpendicular distance can be found. And one more advantage is there, we can get the foot of perpendicular nicely. You just put the value of lambda over there, then you will get foot of perpendicular. So foot of perpendicular is obtained by putting lambda on, at 3 coordinates of L. Lambda at L, what are those points that we have found? x1 plus A lambda, y1 plus B lambda, z1 plus C lambda. Okay, once you get this point, finding A to L distance is very easy. A is x0, y0, z0. So AL will be what then? AL going to be under root x1 plus A lambda, because foot L you got, minus x0 whole square plus y1 plus B lambda minus y0 whole square plus z1 plus C lambda minus z0 whole square. Clear? Put lambda here. You must put lambda here. Put lambda here to get AL. Clear? I think you have understood. Now, after getting L, if somebody had asked you to find image of the point A on the line, this is the line here, this is the point, x0, y0, z0, you got foot of perpendicular here, L you got here, L. You have to find the image of A. Concept of image is the same, the way you have learned before in 2D. That image of A on the line, this is the line here, is that point whose distance from the line will remain the same. I mean, AL must be equal to A dash L. This is the line. AL must be equal to A dash L. Or we can say that to find the image of A, that is at A dash, we take A dash as alpha, beta, gamma. So alpha, beta, gamma we found here, we take here, and A we have already got. That x1 plus A lambda, y1 plus B lambda, z1 plus C lambda. Now since L is the midpoint, of A dash, therefore alpha plus x0 by 2 equal to x1 plus A lambda. Lambda known here. Lambda we have found. I told you lambda is found over there. So we'll put the value of lambda known. And then you can get alpha from here. And beta plus y0 by 2 will be y1 plus b lambda, and gamma plus, this is y0, sorry, gamma plus z0 by 2 equal to z1 plus c lambda. Now, these are three equations you find A dashed alpha, beta, gamma from above. So what we have learned? We have learned how to find foot of perpendicular, how to find the image of a point on a line. Let us practice one or two sums based on it. The question is, so that perpendicular equations of perpendicular from the point to this line are this, and foot of perpendicular. One additional question which we haven't discussed, they have asked. Equation of perpendicular. So this is going to be another advantage of getting the foot of perpendicular. From where to where? From the point A163 to the line whose equation is given here. That line is x minus 0 by 1 and z minus 2 by 3. We go by that method only, which I have explained already. So you take a point L on the line. How to? You take this is equal to lambda. So x, y, z for this line going to be what? X is lambda, y is 2 lambda plus 1 and z is 3 lambda plus 2. Okay? So this point you take lambda, 2 lambda plus 1, and now what is the next step? We find direction ratios of this line. Drs of AL are what? Lambda minus 1, x2 minus x1, y2 minus y1, 2 lambda minus 5, 3 lambda minus 3. These are direction ratios of AL. Now AL perpendicular to the given line. So we use the condition since AL is perpendicular to the given line, therefore 1 into lambda minus 1, 2 into 2 lambda minus 5, clear, or lambda minus 1, 4 lambda minus 10, therefore 14 lambda equal to 20. So lambda going to be what? Lambda equal to 20 by 14, 10 by 7. Once you get the value of lambda, then I told you the point is found out. That L going to be what now? You just put the value of lambda over there. Lambda 10 by 7, you just put. This direction ratio 3 lambda plus 2 minus 3, it will be 3 lambda minus 1. So there it will be minus 3. And this is going to be what? This is going to be 14. 14. So lambda going to be 14 by 14, that is 1. you got the value of lambda equal to 1. Once you get the value of lambda 1, the foot of perpendicular is going to be what? Put lambda 1 over there. It is going to be 0, minus 3 and 0. Okay? So these are actually direction ratios. Direction ratios of AL. Here I found these are direction ratios of this is 3 lambda minus 1 again. Direction ratio, it will be this minus 1. So this part going to be 0, lambda 1 if you put, minus 3 and 2. Okay. Once you get this point L as 0, minus 3, 2, and not point, this is the direction ratios of DRs of AL. So equation of AL we have found out. What is that? A point on AL known and direction ratios are found here. So equation of AL. Equation of AL is what? X minus 1 by 0, y minus 6 by minus 3. Am I clear? So AL, its equation is found out. Now foot of perpendicular is what? L. This foot of perpendicular is going to be, put lambda 1 over there. For lambda equal to 1, 1, 3 and 5. So this part is also found out. That is the foot of perpendicular. Okay. Length of perpendicular, how do you find? AL length. Because the point is found out, 1, 3, 5. So you got the value of A, you got the value of L. Now you can find the perpendicular distance. That is AL. AL going to be under root 0 square, 3 square, 2 square. x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1. So this is going to be root 13. Clear? So we have seen one application where just by using the concept we can get foot of perpendicular, we can get equation of perpendicular and perpendicular distance of the line from a point outside it. Okay, let us take the second example where we are going to find the image of a point on a line. To find the image of this point on the line, I have taken a separate problem for your better understanding. This is a line here. We have to find the image. Concept already explained. This point, let L be the foot of perpendicular drawn from A to the line. Line is given x by 1, y minus 1 by 2, z minus 2 by 3. L must be equal to A dash L. So, if we can find L the way I told you earlier, then we can get the image A dash, because L is midpoint of A dash. So again you go by the same method. You assume that let this be equal to lambda. So x, y, z going to be what? This is going to be lambda, 2 lambda plus 1 and then 3 lambda plus 2. Okay. So the point A, we have taken lambda, 2 lambda plus 1 and 3 lambda plus 2. This is the point on the line, that's why. Now we find drs of AL. Drs of AL are what? Drs normally I keep this manner, lambda minus 1, 2 lambda minus 5 and 3 lambda minus 1. x2 minus x1, y2 minus y1 and z2 minus z1. Okay. Now AL is perpendicular to the given line. Since AL is perpendicular to the line given, so you can use the perpendicularity condition. Direction ratio of AL here and direction ratio of lines are over there. So perpendicularity condition will be lambda minus 1 into 1, 2 lambda minus 5 into 2, 3 lambda minus 1 into 3 equal to 0. So 5 lambda, 9 lambda, 14 lambda equal to 14. Here also we got the same thing, lambda equal to 1. Once you get lambda equal to 1, once you get lambda equal to 1, then foot of perpendicular is found out. This AL going to be what? 1, 3, 5. Now it has to be alpha, beta, gamma. So AL is the midpoint of A dashed. Therefore, A dashed we have taken alpha, beta, gamma. Alpha plus 1 by 2 equal to 1, beta plus 6 by 2 equal to 3, gamma plus 3 by 2 equal to 5. So alpha equal to 1, beta 0 and gamma is 7. So the image of the point going to be what? The image of the point is 1, 0, 7. Clear? Hope you have understood. Now, what to do when vector form is given? Okay, you take in the form of position vector. Position vector of the point be alpha, and this is the line whose equation is given r equal to a plus tb. Your problem is to find the foot of perpendicular. See, method is clear. If you say that I will convert into scalar form, then I will do it. Then it's fine, you do it if it is convenient for you. But my duty is to show you with the help of vector method also. So what I am doing here, that arbitrary point on the line I have to take. That point whose position vector is a plus tb can be taken. That point as L can be taken in this form. A plus t into b. This t is a scalar. Because this, when you take a plus tb, it is representative of all the points. So we take L equal to a plus tb form. Now drs of PL are what? What are the drs here? Drs of PL, or you write PL vector this manner. PL vector is what? Position vector of L, position vector of P, that is A plus T into B minus alpha. Clear? You know it very well. PL vector is position vector of L minus position vector of P. Since PL is perpendicular to what? PL is perpendicular to the line given. Therefore, PL dot perpendicular to line given means what? The vector B, because this line directed along the vector B. So PL dot B must be equal to 0. What is PL we got here? A plus TB minus alpha dot B equal to 0. So we need to get the value of T. This will ensure the point L we have got. Okay, how to get? You just take the dot product. This is, you separate this, A minus alpha dot B plus T B dot B equal to 0. B dot B is what? B dot B is nothing but mod B square. So therefore, A minus alpha dot B T into mod B square 0. So T is what? A minus alpha dot B by mod B square. Clear? Hope you have understood. So you got the value of T over there. T is A minus alpha dot B by mod B square. And this will tell you the value of, sorry, there is a minus sign over there because you transfer it on the right side, no? So T is going to be minus of this thing. So the point A is found out. You put the value of, put T equal to minus in L that A plus TB. I am telling you the method, I am not putting it there. Then what is the value of this length of perpendicular? So mod PL, the distance, the length of perpendicular, foot of perpendicular you got, you put the value of T over there. Length of perpendicular is mod PL. Mod PL is what? That point P you have taken alpha, so mod of A plus TB minus alpha. Okay, done? Understood? So let us solve it now to find the foot of perpendicular drawn from the point 2I minus j plus 5k on the line whose equation is given as, in vector form obviously, 11I 2j minus 8k plus lambda into 10I. So we take this foot of perpendicular as this form only. What form? That in vector form it is 11 plus 10 lambda I cap. Take this manner. The point L you take this way, and j minus 4 lambda plus 2 into j, and then minus 11 lambda plus 8 into k. Okay. Now this AL is perpendicular to the line given. So we will find drs of AL first. What are those? Drs of AL. I mean, or you find, not drs, you just find the vector AL. AL vector is what? AL vector, because we will solve it completely with the help of vector concept. Position vector of L minus position vector of A, that is 9 plus 10 lambda I cap, and this is minus 4 lambda plus 2 plus 1. So minus 4 lambda plus 1 g. Okay, and minus 11 lambda plus 8 minus this thing. So this will be 11 lambda plus 13k. Hope you have understood. Position vector of L minus position vector of A. Okay. Now AL is perpendicular to the line given. So the condition is what? Line is directed along this vector. I mean, you can identify the vector B over there for the line. That B vector is what? 10I, 4j, 11k. Perpendicular to the line means perpendicular to the vector B. So condition you get, the dot product must be 0, that AL dot B equal to 0. So 10 into 9 plus 10 lambda plus 4 into 4 lambda plus 1, 11 into minus 1 plus 11 lambda plus 13 equal to 0. Solve for lambda from here. That 100 plus 16, 116 and 121. 237 lambda going to be minus of 90 plus 4 plus 132. Okay? Clear? Because we take 90 on right side, 4 into 1 on right side, 13 into 11. That is 143. Sorry, 143 over there. So 147, 90 is 237 only. So it is minus 237. Lambda will be minus 1. Once you get the value of lambda, then L is found out. L going to be what? That point L can be written over there. That L going to be lambda minus 1 you put, that is I minus 4 plus 2. Minus 2, this is plus 2j, and minus 11 plus 8 minus 3 plus 3k. So the point L's position vector you got, that is I plus 2j plus 3k. Clear? Not a difficult one, just you have to do it carefully. I got the foot of perpendicular. Foot of perpendicular, as you are doing vector form, position vector, you have stated, that is enough. That L you got I plus 2j plus 3k. Now mod L you find, then perpendicular distance can be found. I find it here. Mod L is going to be, you can use distance formula, you can use that modulus of L vector, that is I minus 3j plus 2k. So this is going to be 1 plus 9 plus 4, root 14. I found L modulus. If you write position vector of A minus position vector of L, you got this one. L minus A also minus I plus 3j minus 2k. Modulus will be the same value, that is root 14. Okay? So this way, in vector form also, we can find the length of perpendicular. Now, let us take another example to find the image of the point 1, 2, 3 on this line. Its vector equation given again, R equal to that 6i, 7j, 7k. We have to take the point. So I am not writing it again. I am taking foot of perpendicular L as what? 6 plus 3 lambda method is same. We have to get the value of lambda over there for this particular point. So let L be this I 7 plus 2 lambda j plus 7 minus 2 lambda k. Alright. So now use the condition that AL is perpendicular to the given line. Given line is directed in what direction? Direction of the line is along the vector B. R equal to A plus TB form. B is what? 3I 2j minus 2k. Okay? B vector directed this way. Now let us write AL vector. Vector method, at least a few steps. Okay, I will not comment, you will decide whether it is longer or shorter than the scalar method. But I will discuss fully in terms of vector form. L vector I am finding, no point over there. Don't mix up. Either you follow vector method or scalar method. So L vector, position vector of L minus A, 5 plus 3 lambda I cap and 5 plus 2 lambda j cap and 4 minus 2 lambda k cap. Clear? Now we got the vector AL. Since AL is perpendicular to B, therefore AL dot B will be 0. AL dot B is what? 5 plus 3 lambda, 5 plus 2 lambda, and then okay, that dot product must be 0, L dot B must be 0, we got this. Or 15, we take all lambdas together. 9 lambda plus 4 lambda, 13 plus 4. 17 lambda equal to minus 15 minus 10 plus 8. We take it on right side. This is coming to be minus 17. So the value of lambda is minus 1. So the vector L you got. L is what then? L going to be, L has position vector, put lambda equal to minus 1, 3I and 5j plus 9k. Okay? We have to do it by vector method only. In vector method, you got position vector of A. They have given 1, 2, 3. I plus 2j plus 3k. We are going to find the image. So image is here, that A dash, L is here, 3I, 5j, 9k. And the point given is 1, 2, 3. We change into vector, position vector. Clear? I plus 2j plus 3k. You got AL, but A dash is the image. This must be equal to this. Let this one has position vector alpha. So use midpoint form now. Okay? So you can write that OL vector equal to OA, midpoint formula in vector, by 2. We have done in vector episode. If this is a midpoint, then position vector of L is given by position vector of A, position vector of A dash by 2. Or OL going to be what? That position vector of A, O is the origin, however we don't know, it is I plus 2j plus 3k plus alpha by 2. OL we have got, OL is what? 2 into OL, that is 2 into 3i, 5j, 9k equal to I plus 2j plus 3k plus alpha. So the value of alpha is found out. Alpha is what? 5i 10 minus 2 and 18 minus 3. So you got the image of the point A as A dash, whose position vector given by this. In vector form, this much expected. Point they will not mention. If they mention, then point you write 5, 8 and 15. And by solving these simple sums, I have explained how to get foot of perpendicular, the length of perpendicular, even the equation of perpendicular. If you want to find the equation of perpendicular, that also can be found out. Clear? Hope you have understood. Approach all the sums from your book, and if you face any difficulty, you send me in WhatsApp or comment over there. I'll definitely give you the feedback. I'll definitely guide you. I'll definitely help you to solve the sum. Okay? Thank you. See you again next episode, where I am going to discuss that shortest distance between two parallel lines and between two skew lines.